All right, so thank you to all of you who have joined us a bit early and sat through some of the technical issues and just getting ourselves prepared to launch the first workshop in the series presented by the University of California, Riverside for the Association of Pacific Rim Universities Virtual Student Exchange Programs. The series is called Studying and Living in an American Research University, and we welcome all of you. Although it's 6 p.m. Pacific time, we are aware that you all are in your own respective times, depending on your global positioning, and we thank you for taking time out of your day to join us. Our first speaker comes to us from our own Bourns College of Engineering. He is an Associate Dean of Student Academic Affairs at the Marlin and Rosemary Bourns College of Engineering. He is a professor of mechanical engineering, and he recently took the position as interim vice provost of international affairs. He starts off our series with an introduction to American research universities. If you would, please have your questions ready and enter them in the Q&A. And also note that all of the workshops are going to be recorded, and those recordings will be made available to you at a later date. So without any further ado, Professor Marco Prinsbeck.
Yeah, thank you, Melly. Thank you everybody for coming right on our first of 10 series about living and studying at American Research University. As Melly said, this first presentation is general introduction to American Research University. And then we will cover different topics, right? There will be next presentation will be on American classroom and cultural adjustment, about academic honesty, about career employment opportunities, then how to select graduate program, on leadership, on wellness, and so on. And you see, we will conclude with a presentation about American culture in a nutshell. So I hope you will enjoy this, this series of presentations. I mean, you can hear my accent. I was international student in the US, right? I experienced culture shock. I was surprised how America is different than the rest of the world. So I wish I had presentations like this to help me when I was moving into US. Well, let me tell you, it's not that I was only international student. I was also participant in a student exchange program. So I would like to start this presentation a little bit about my story, and I will tell that story through flags, right? So I was born in Europe, in a country that was called Yugoslavia. That country does not exist anymore, but now there are 6 countries instead of Yugoslavia. And I was born and raised in Belgrade, what is now capital of Serbia, right? In my undergraduate days, I went for a student exchange program in Mexico. And that was life-changing experience. I mean, imagine a young man from Europe comes to Mexico. I had a blast. I learned so much. I was exposed to different culture. It was really life-changing experience, and it was so good. It motivated me. Then after my undergraduate studies, I decided to go for a graduate studies abroad, and I did select United States. And specifically, I went to Arizona in United States. So again, very different from Europe, desert environment, very exotic at the time for me. Well, being in United States, right, everything can happen. So in United States, as a graduate student, I met a lady from Korea. She was actually a professor in Arizona. You see, we got married, and we are still happily married. Once when we got married, we decided we want to stay in United States, and we selected California. And we love California. Nobody will ever move us out from California. Having said that, I also have a brother, and he decided to live in United Arab Emirates. So basically I have in-laws in Korea, my parents are still in Europe, my brother is in Middle East, and I'm living in California. So really nice. About my professional life. So being a professor and also graduate student in major research university allowed me to have a projects with partners all across the world. Here is me at one project in India. I mean, there were many, many projects in India. Me in Sri Lanka, where I really like this saying, scientists study the world as it is, engineers create the world that never has been. Well, I'm an engineer, so I really like it. I had projects in Chile, right? I had no, I mean China is a huge country. I mean I traveled China all across, collaborated with many universities, signed contracts with many universities. Oh, just a few weeks ago with my collaborators in Mexico, we were studying air quality in one Mexican village, and here you can see simulation of results on air quality from Mexico. And I got reminded that last year at this time, so pre-COVID, one of our professors, he is a chair of mechanical engineering at UCR, got inducted to Mexican Academy of Engineers. And this is me, a chair of mechanical engineering and director, president of Mexican Academy of Engineers. I will be talking about quality of faculty at research universities in America later. Okay, a little bit more about me. If you Google my name, if you, whatever search engine you are using, if you put my name, you will find a lot of videos and pictures of me and my fire projects. So I say I like playing with fire. Actually, it's not me, it's mostly my students, right? Both undergraduate and graduate. But I do like playing in sailing, and let me continue a little bit with flags. Of course, I sail across United States, Puerto Rico, Mexico is just south of border, Costa Rica, Panama, US Virgin Islands. So still did not sail in Asia, but soon. Okay, so much about me. I'm just excited about all this international experience. And as you can see, international experience shaped my career. So I'm always encouraging students, go abroad, do something different, don't just live at your place. Now, if you decide to go abroad, you need to select university or wherever you want to go. That's why we decided to talk here about American universities, but not any American university, but American research universities, right? So, I mean, who cares about research, right? Why research? There's so many books around, right? Just go to library. Actually, nobody's using libraries anymore. Go online and you will find information about everything, right? We know it all. And think about your professors. Your professors know everything, right? They're full of knowledge, right? Well, that's so wrong, so wrong. And well, actually, when I was undergraduate students, I did believe that professors know everything. And that is what I like in American education that I did not know when I was undergraduate in Europe. Here, in order, for example, any engineering program to be accredited, that program has to prove that within a program we are explaining to our students that learning never ends, that whatever we do is what we know right now, but much more needs to be done. And this is taken, ABET stands for Accreditation Board of Engineering and Technology, very important body that accredits universities in the United States, but nowadays universities worldwide are going after American accreditation, right? You see, one criteria is ability to acquire and apply new knowledge. So we need to explain to our students it's never enough to study. Okay. I think I already alluded to this. The more you study, the more you realize how little you know, right? So that's why we need research, right? Research, I put it as equal to creation of knowledge. while teaching is only transfer of knowledge, right? So there is nothing wrong with pure teaching university. They teach, but they don't create knowledge. And in research universities, in addition to transferring knowledge, they create knowledge. Let me go. Okay, so that was my interpretation of research universities. They are actually formal definitions of research universities. So here you can see that US National Academy of Sciences defines research universities as those with highly intellectual freedom, creativity, excellence, openness. Of course, has to have faculty engaged in research. You will never have a faculty in research university that is only teaching. We'll be talking about that. Strong graduate programs are a must in a research university. At some schools, you can get master degrees without doing research, right? Those are usually in teaching schools, right? For PhD, major research is needed. Okay, let me show you some numbers. There is a lot of universities in the United States. You see, almost 4,300. But only 1,000 universities in the whole world is ranked as a research university. Out of 4,000, or this 1,000, 266 universities in the United States are ranked as a research university. And now also not every research university is equal. So among these 166, only 131 university is so-called R1 university. So those are universities with very intense, very high research activity. Okay. Well, I'm coming from University of California, Riverside, right? So I will focus on University of California. Well, there is a reason, right, for that. University of California is one of the biggest systems in the world, but definitely the biggest system in United States. Let me go to next slide. So you see, University of California system, it dates back to 19th century. And the first campus to open was Berkeley, UC Berkeley, right? After that, new campuses have to be open. So UC Berkeley, UCLA, UC San Diego. And you can see here now we have 10 campuses, many academic disciplines, almost 800 programs, a lot of students. We are a system, I believe, the only system in the world that has 64 Nobel Prize winners. Okay. Let's focus a little bit more on UC Riverside. So we are in Southern California. If you join our meeting before, I was telling how it's nice and warm. I really like warm weather. Right? One of the reasons why I left Europe is I like warm. So that's why I went to Arizona, but then I moved to California because I like sailing. Ocean is very important to me. Nobody will ever move me out from California. If you don't know where Riverside is, you probably know where Disneyland is. Let me see, yeah. So here is Riverside, just east of Disneyland. There is Hollywood here, Malibu is here, LA is here, San Diego is south of us, there is Palm Springs, all kind of national parks. San Francisco is 700 kilometers north, right? Okay, so just in the South California, north of San Diego, east of LA, and there is Riverside. Yeah, rankings are important. I will not spend time talking about ranking. I mean, everybody's familiar with ranking. We are ranked #1 in social mobility by US News, best value college by Forbes. We are number 12. Money Magazine also number 12, so that means the best return on investment and so on. Yeah, you can find this ranking. I will not be spending time on that. What I want to say, again, we are talking about research universities. University of California, Riverside started as a citrus research station. So in your countries, I'm sure you can find variety of oranges. Some of these oranges were actually created here at UCR. So we have patents of variety of oranges. Let me show you. So in mid 19th century we got land. Then at the beginning of 20th century we became experimental station, citrus experimental station. Yes, I'm coming from engineering, but our College of Agricultural and Natural Sciences is very strong, and they have very strong agricultural programs. If you think food is a major thing, and we are one of the leaders in food, so we are leaders in food, environment, you will see more. And we became university in mid last century. And now we are in 2020, we are ranked as the fastest rising university in the United States. So we are on really fast trajectory. Okay, now you have some idea what is research university. So let's go again through how can you recognize a research university. So first, look at their faculty. Faculty always post resumes, CVs online, open their CVs and see how many publications they have. How many publications in the last year? Are they research active, right? So usually on R1 institution, depending on the field, faculty should have more than one publication per year, sometimes much more than one. So having 20 publications per year is not rare. Some discipline is less, few publications per year. You cannot have a R1 university without strong, well-ranked PhD program. Research center, every research university has a variety of research centers. We will go through research centers later. And whenever you have R1 institution, people are approaching that institution with questions. They give money to that institution to explore different projects, different questions, right? So government agencies and companies are always working very closely with R1 institution, either purely through grants or those are collaborations or having their faculty consulting. So very close connections in a project, not just hiring their graduates. Let's see, yeah, I mentioned faculty. What does it mean, high quality faculty? Well, it's fantastic if you have a Nobel Prize winner among your faculty. UCR has two. See, here we have Professor Schrock. He won Nobel Prize in chemistry in 2005. And it's not just that he is a Nobel laureate, but he is also UCR alumni. He received a degree from UCR. Another Nobel Prize is Professor Barish, and he received the Nobel Prize in physics. Of course, not everybody, high quality doesn't mean everybody has to be Nobel Prize winner. There are so many other awards, right? Like here, we do have 2 Nobel Prize winners. We do have 12 members of National Academy of Sciences, 5 members of National Academy of Inventors, 3 members of Academy of Engineers, 1 member of Medicine, Arts and Sciences, 5 members, and Arts and Letters, 2 members. So really high quality. How do you achieve this? This is not, all these achievements do not come from good teaching. In every R1 institution, everybody has to be a fantastic teacher. And then on top of that, these awards are given to very productive researchers. What about programs? I did mention R1 institutions are characterized by a lot of doctoral programs. So at UCR, we have 42 doctoral programs. Look what Undersecretary for Education under our previous president says. I wish I could clone what is happening at UC Riverside and bring it to every college and university in the country. Well, I did say we are now the fastest rising university in the country. So these programs, 42 doctoral programs, are spread across colleges and schools. Now, sometimes colleges and schools They are used interchangeably. How I see that colleges are maybe more comprehensive, start with graduate, different undergraduate degrees, and then have different graduate programs. So we have a College of Engineering, Humanities and Arts, Social Sciences, Natural and Agricultural Sciences. Then we also have schools. So schools are kind of more geared towards professional degree, and not so much undergraduate, right? So School of Medicine, School of Business. I think our School of Business is ranked number 10 in Asia. Very, very popular, actually, all of our schools. School of Public Policy, Graduate School of Education, so it's kind of more professional degrees. I like this story a lot. So yeah, we do have a College of Engineering, but look, our College of Engineering is named, and it's called Marlon and Rosemary Bournes College of Engineering. So this is a picture of Marlon and Rosemary, and they are founders of Bournes Incorporated. If you're not familiar with Bournes Incorporated, go online, find this company. It's a major engineering company founded by Marlon and Rosemary. They have manufacturing all around the world. Their headquarters are in Riverside. They sponsor our students. They serve in our advisory board. So we are really proud to be named after founders of such a major engineering company. As any engineering college, we have mechanical engineering, electrical and computer engineering, bioengineering, chemical and environmental, computer science. We have computer engineering, material science. We have PhD programs in all this area, and also per request of local industry, we created this online master program because local companies do not want to give their employees time to go back to school. So, but they need extra knowledge. So we developed this online program. Again, ranking, I will not spend time here. So US News and World Report, each program is ranked, computer science program. Oh, this is interesting to note. Starting salary for our graduates average is $72,000, and then just keeps on building from that. So and we are talking about a bachelor degree. And yeah, we have another ranks. Enough about engineering. This is about our College of Natural and Agricultural Sciences. So we have all these undergraduate programs, mathematics, biochemistry, chemistry, physics and astronomy, and also graduate programs. What I want to mention here, yes, R1 universities, it's all about research, lot of research, laboratories, grants, patents, publications, but you cannot just keep students inside the lab. You need to provide them. It's not enough just to be good in whatever you're doing in lab, whatever you're doing in your research. So you need to publish those results. So every R1 institution will provide a writing assistant teaching you how to write. And that's especially important for international students, right? I mean, it helped me a lot. I mean, back when I was a graduate student, writing in English is not easy for international people. All of our students, graduate students, it's mandatory for them to get experience in teaching. So we always expose them to teaching. They're always teaching assistants. They are mentored by senior graduate students, and there are also other jumpstart programs that help you not to succeed only in the lab, but to publish that, to grow as a professional. We receive a lot of funding. So whoever joins our doctoral programs doesn't pay a cent. We cover their expenses through our external grants, right? But yeah, you have to work towards your degree. So you're basically paid to get your degree. I will mention that also later. We very rarely sponsor master students. Why not? Well, master students come, they finish their degree in 1 year, they got a job in local companies, start making money, and we don't get much from them. So they're there just to boost their career go with a starting salary that is much higher than after bachelor and go. So it's fantastic investment for students, not good investment for us. But anyway, it works. So that's nothing wrong. I mean, yeah, I do encourage, go to master program, finish in a year, get fantastic job and so on. Let's talk a little bit more. So yeah, you have option. You can go to really research intensive university or teaching university. In one or another, you will get your degree, right? You just take enough classes, get good grades, and you are done. Well, if you're undergraduate in non-research university, what can you put on your CV? Well, you can put, I was fantastic student, I have really good grades. I got very good grades in these subjects, right? And probably you joined some club, you participated in some club activities and so on. But now compare that to a student that goes to research university. This student, I mean, all research universities, especially UCR, we are very proud that all of our undergraduates are participating in our research. When you are undergraduate doing research, you are very likely to participate in journal publications, conference presentation. You may be co-author on a patent, and you put all these things in your CV. That is now completely different level than if you are taking only classes. And especially if you want to go to graduate school, if as undergraduate you have journal publications, conference presentation, patents, your entrance to graduate school is smooth. If you are going to graduate degree, well, if you are doctoral student, right, you will be sponsored to do your research, and you will be mentored by highly accomplished scientists. So yeah, you will always get degree, right, and from teaching university, but research university provide much more, right? Just, I think I put somewhere here. No, yeah, research university just brings your market value at a different level. Let's talk a little bit about research facilities, right? So it's not enough to have classrooms. I said every research university will have research centers and also laboratories. And this is actually a picture from our laboratory in material science and electrical engineering. So basically they're here creating new materials. We have a lot of centers like brain game centers, centers for spatial sciences, high power computing, Center for Advanced Neuroimaging, Catalysis Center. Oh, maybe you know, maybe you don't. But in California has probably the most strict environmental regulations in the world, definitely in the United States. So you can buy some vehicle that is okay to drive outside of California, but you cannot register that vehicle in California because California emission standards are much higher, which are much more stringent. Right? So we have Center for Environmental Research and Technology that works very closely with Californian government in testing and establishing standards for clean air. Not just clean air, right? Clean water and everything. In addition, for environmental research and technology, we have Center for Nanoscale Science and Engineering, Winston Chang Energy Center, Industrial Biotechnology, Cybersecurity, Neuroimaging. Oh, we have international centers. So this is UCR Kings, University of California, Riverside, Korean Institute of Material Science, Center for Innovative Material. Center for Communication by Light and Intelligent System. Let me just give you flavor what is happening in these centers. So in a Center for Environmental Research and Technology, we have our own patents, our own recipes to cook renewable fuels, right? And just general energy management. We work on vehicles, combustion, so we have combustion chambers, we have test vehicles. We have environmental chambers in which we model atmospheric chemistry. So we are studying pollution formation in the atmosphere. We're looking at exposure and health impacts, and lot of transportation research related to smart vehicles, autonomous driving, and so on. Center for Nanoscience, Scale and Nanoscale Science and Engineering. Here in this center, we basically build new materials, starting from nanopowders, sometimes creating nanopowders, and then processing those nanopowders to come with different materials with different properties. Oh, Center for Advanced Neuroengineering. This is a joint with the School of Medicine, right? So here we have Professor Hu, right? He is chair of our bioengineering department and expert in imaging, right? Bioimaging. And together with the School of Medicine, this center looks at Parkinson's disease, Alzheimer's disease, Lou Gehrig disease, and all kind of different projects. We have Winston Chang Global Energy Center. So long time ago, power distribution used to be simple. There was a big power plant, and that power plant is producing power for local cities, local state, and so on. Now it's not so simple. Lot of houses, lot of schools, lot of hotels have their own power plants. Now it's mandatory for all new housing in California. They have to have solar panels on the roof. So sometimes they produce just enough energy for that household. Sometimes they produce more than they need, so that has to be fed back to grid, stored somewhere. And then when they don't produce enough, they have to pull from the grid. So there are now a lot of new problems about energy generation and energy distribution. And we have center dedicated to energy. I did mention our research is sponsored. So these are some of companies that sponsor our research. In addition to companies, fundamental research is commonly sponsored by federal government, by state government, or local government. Right? If there is some local air pollution problem, then usually local government funds us to investigate that pollution problem. No research is located only in one major, right? Most of research goes across college, right? But here we have multidisciplinary research building in which we have 3 colleges, right? Medicine, engineering, and natural sciences working together, sharing lab, working on joint projects. Brand new building just opened. I mean, you can see how by appearance of a building, the more glass, it's newer building, less glass, older building. So this building only has glass. Let me run you through several research projects just to give you a flavor what's happening, and please allow me to start with my projects. I mean, whenever you turn on news, unfortunately, California, there are always fires in California. So those fires, I mean, it's hot here, a lot of dry fuels and climate change. Those fires will keep on going. Fortunately for my research group, we have a lot of funding to pursue research on fire. Here is one experiment in which we were looking under which conditions surface fire can transfer to canopy fires. We have our lab in which we run these experiments. You can see this plane behind me. We are not allowed to do fires outside, but we collaborate with United States Forest Service. And when they are doing prescribed burns, we join them. And here you can see during one prescribed burn, a really strong fire was developing, and the guy behind me had some problems. What we can do in the lab, here is one example. So this is fire in the lab, and here we show how nice flow visualization we can make in front of fire. So by visualizing these flow structures, we can build a model that help us model how fire propagates, right? Because this is simple convective motion for those of you that are interested. Yeah, we study fire at different stages, from ignition to major flaming, and then through smoldering. Oh, I like this project, also done by my lab. Hummingbirds they're very common in California, not so much in the rest of the United States, but I know they're also in South America, they're common. If you don't have hummingbirds, they're really fun to watch, and they're famous because of their really perfect hovering, right? So they can fly in a place, right? And that's why people love them. So we built a project in which we were looking how hummingbird can stay in place. So together with the partners in biology, we would catch a hummingbird, put it in a chamber, we would inject olive oil in that chamber, and then we would be taking, as bird is feeding, we would be taking pictures of olive oil droplets in this chamber. By the way, I'm a big animal lover, so I wouldn't allow any animal to be hurt. So these birds were caught, fed, and released. And then we measured several birds. So here you can see our results. These white dots are basically olive oil droplets under bird. And now imagine taking many pictures of these olive oil droplets and then doing correlation between these images. You can reconstruct really detailed flow field around hummingbird. And by looking at that flow field, okay, if you go to online, you can find pictures like this. Basically, it says hummingbird flies by creating a single jet under. But that's not what we saw. We saw evidence of a jet under each wing. So instead of this, we proposed that and we published that. And then some people did not believe us. We said, okay, let's do flow visualization. This is dry ice above hummingbird. You can see one jet on one wing, another jet at another wing. So here, each jet is producing each wing is producing its own jet. And then we were looking more into details of how hummingbird is producing these jets and so on. So you can see here is one jet, here is another jet, no jet in the middle. Now everybody believes us, and this is well accepted model of how hummingbird hovers. We went into more details to explain that this is interesting question for you. So why hummingbird is flying with the two jets? Why not with one? Answer to that is, imagine a drone with one propeller. No, drones have at least 4 propellers, quite often 6, even 8. Why? More stable, easier to control. So same reason is hummingbirds are famous for being perfectly maneuverable, right? And now that's much easier to do if you have 2 jets than if you have one big jet down. Well, we assume when hummingbird moves into forward flight, we'll switch to more energy efficient mode. Let me show you some other projects, obviously sponsored by Disney. Well, some of them are getting pixelated, but we will repeat them. Look at this water. Okay, I will repeat these animations. Let's see. Yeah, look at it. This looks real because these are not drawings. Look at this. Bang. These are not drawings. These are visualizations of a solution of behavior of the formable body. In case of water, this is solution of Navier-Stokes equation, right? Not a drawing, but actual solution of equation. We have more, right? Some phase change here. Let's see if I can correct this. Yeah. Yes or no? But okay. So, go, sure, play. Doesn't want to play. Anyway, so we have very strong computer science department that is focusing on visualization, computer graphics. They're also famous for cybersecurity. This is our chair of mechanical engineering. I show his picture from his inauguration into Mexican Academy of Engineers. This is one of his projects, basically biocompatible material that can be used to close a skull after brain surgery. And that biocompatible material is also transparent. So now the skull is closed by titanium. So if there is any need for laser diagnostic, the titanium plate has to be removed. Now with this, there is no reason to open skull again, because the laser diagnostics can be done through that new material. Oh, another project from bioengineering. So that is magnetic gel. So this magnetic gel can carry medicine, can be injected wherever it's needed to be injected, can be driven by magnets wherever it's needed, kept there, and when it's not needed anymore, that magnetic gel is taken out. More projects on air quality. So this project was sponsored by California government, right? And this sponsor basically resulted from a fact that companies were approaching Californian government to endorse some cleaning device, and they were claiming if you inject hydrogen in diesel engine, then emissions of nitrogen oxide will go down. There was no reason for that to happen, right? Doesn't make sense. Anyway, Californian government approaches. We build this setup, so we took a diesel engine, we put injection system of hydrogen, and then we were measuring emissions of nitrogen when we inject hydrogen, dark lines versus there is no hydrogen, white lines. As you can see, it doesn't make any difference. So Californian government did not endorse that product. And we measure all kinds of particulates and so on. So this is part of that CSERT studies. More, I like this animations a lot. Again, looks real because it's solution to equation, not just drawing. I like this mixing of two fluids. See, heavier fluid up, lighter fluid down. Oh, and my favorite with the fire. So here we have a ball burning. Again, this is not a drawing, this is actual combustion solution. There is flammable fluid down. This ball will come in touch with that flammable fluid and fire will keep on spreading. Well, I love talking about research. I hope I gave you some idea of what kind of projects are happening at our university as example of R1 universities. What is the point? Yeah, each professor in research-intensive universities has multiple projects. In our engineering college, we average of 6 projects per professors, right? And how many projects did I show you, right? I don't know, 5 maybe, 4? And at any time, so we have 120, wow, over 600 projects just in College of Engineering. And all of these projects are open to undergraduate students. Yeah, well, let me go back to the rest of university. Yeah, research university, it's not only about labs and research centers. Yeah, that's important. But we want our students to be healthy, right? To have a fun, so they can work, they can produce more, right? And just be happy. So we feed them well. We have several campus restaurants, we have dining halls. I mean, we are doing this remotely because of COVID. So our dining halls, our dorms are open, but at decreased capacity. So everything still functions, but with COVID prevention in place. Yeah, many famous restaurants are along campus, right? Habit Burger, very good burger if you did not try it. We have different food trucks across campus. Our very traditional barn restaurant. So we feed students and we provide really nice housing. As I said, we are growing university, we keep on adding housing quite a bit. this is a main campus is here, and then housing is all around campus. This blue are department, this orange are student dorms, and say a lot of things to do. Well, food, housing, that's not enough. You need to enjoy your life as a student, right? It's whatever student lifestyle means. We do have different student organizations. We do have athletics. We organize concerts. There are outdoor excursions. Nice student recreation center. I think I have a slide about it. We do take care of health of students. We have counseling center. We have student health center, women resource center, LGBT center, and so on. So really comprehensive care of students. Recreational activities, again, this is new. There used to be old one that was also good, but now this is different level. I think this is what, 3 years old. I love ocean, I love swimming, so I love swimming pools, right? If you are not into swimming, there is everything else inside. We have indoor climbing, dance classes, martial arts, yoga, tennis, soccer. Our soccer female team is very strong. We have basketball team, and so on. I mean, we do take care that our students find job, right? I mean, you cannot go to bad reputation if your students are not finding jobs. So we do have career center. And by the way, yes, so I'm now vice provost of international affairs, and we are making sure that our international students have special programs for them to find the jobs, either in academia or in local industry. And there, all these companies, they have programs for international student, international workers. Well, I said R1 characteristic is strong graduate program, particularly PhD. Yeah, we do have PhD program, whatever I said, 54 PhD programs. We have medicine doctor, Master of Arts, Master of Science, Master of Education, Master of Business Administration, Master of Finance, Master of Professional Accounting, Master of Public Policy. So this is very important that I did not know when I was international student. All of our programs gives to students, international students, at least 12 months of working permit. So after your graduation, students are eligible for 12 months. Or 3 years if you are in STEM medicine, in STEM field, science, technology, engineering, and mathematics. So if you're in science, technology, engineering, or mathematics, we will help you get 3 years, 36 months optional practical training. Wow. Guys, I'm really enjoying talking about this. I kind of reminded myself when I was a student, and wish I knew these things that we went through. So I think I have to stop here, and we are open for any questions. Thank you. Thank you. Yeah, here you can visit our website. It is just virtual tour, right? It's not admissions of application. It's just virtual tour of this. And please, if you have questions, visit us at International Affairs, international.ucr.edu, and we are happy to answer any question. Thank you.
Marco, can you hear me?
Yes.
So we have a student, Francisca Reynoso, who has asked a very interesting question. She wasn't sure if you had mentioned this or not when you were talking about engineering. She studies food engineering. Is there anything like that happening at UC Riverside?
Well, I mean, that would go probably in College of Natural Sciences. But first let me tell you, we have a program about sustainability of food. So yes, answer to your question, we do have programs that deal with food. Now, I'm not sure what you mean by food engineering, because I mean, I did mention that our agriculture department is very strong, and they're, let's say, engineer they engineer different oranges and different varieties of agricultural products. So answer to your question is likely yes. I don't think we have anything under name food engineering, but please follow up, send me email, and I will try to connect you with the best program. You can find out more. I hope I answered it. Remember, questions can be about anything. It can be how I felt when I was international student in US. I was confused. Yeah, but I highly recommend expose yourself to something different from your country. I think we are receiving now questions.
Marco?
Yes?
Do you want to talk a little bit about research universities and field extension and that role?
Field extension?
Yes, so traditional extension, we have faculty who are professors, but they also have research in the field.
Oh, I mean, so depending on a professor, right? Every professor at research university has to be research active, right? So now, well, you see, also my fire research, I consider field research because I take students outside in the field when forest fire is, Forest Service is doing prescribed burns, then we study fire in the field. And a lot of disciplines can only do field research, right? All kind of forestry, agriculture related. Is that the question that you are asking?
Yes, I was also thinking about, we have faculty that do work with strawberries, cowpeas, and they're very connected with industry groups as well.
Correct. Yeah, thank you for reminding me. Yeah. Yeah. There is a question about math education. So I know that our math department is strong in field theory, and so I presume talk about the graduate program, and we do have undergraduate degrees in math and graduate degrees in math. And keep in mind, I mean, uh, in any program that is in STEM, either engineering or natural sciences, there is a big part of math. So we all collaborate with math closely on different things. I show these solutions of Navier-Stokes equation by computer science. So solutions of Navier-Stokes equations are major field in math departments. June, anything that you would like to add, or we are good?
I think we're pretty good. Yeah. I think the time is almost up.
Yeah.
So
I hope you got some idea, and we are here to answer questions. And join us for a next session. It will be very different topic, right? You see, there will be about U.S. culture, different presenters. Some of them will be professors. Some of them are professionals, career professionals, health professionals. So you will hear from really different parts of a university.
Marco, since we have a few minutes and Michael's with us today, maybe he can or you can talk a little bit about the International Affairs Office and its support of international students.
Well, there's an office called International Students and Scholars, and I happen to be the director of that office. I'm new, And it's a part of international affairs. And we're really happy to be here. And Marco is my boss. And so it's really great to hear what he had to say about research, because I'm a humanities major. I studied languages and literature, and I wouldn't know what research is in the engineering sense in the slightest. But we're really happy to have international students, no matter what your interest is, whether it's in the hard sciences, the social sciences, in the humanities, or the fine arts. UCR just has wonderful programs for you here. But what's, I think, even more important is you have a wonderful group of people in the International Affairs Office who are here to make your transition coming into the United States, your transition to becoming acculturated to life in the United States, so that you can be successful in achieving your educational goals, because that's exactly what we want. We want you to be successful. And as what Marco was saying, it's not just about the education, it's also being able to get a job after you're done. So we also want to help you prepare for your professional goals as well. My office works with immigration matters. And so we're the office, one of the first offices you're going to have contact with when you come to UCR, because we're going to reach out to you and we want to get certain documents, and we're going to want to get what we need to be able to issue you your visa documents so that you can then go to the embassy, get your visa, and come into the United States. But our relationship with you doesn't end there. It continues on. After you get here, we continue to work with you for the 2 years, the 4 years, the 6 years, or however long you're going to be at UCR, so that you can maintain your status, but you can be successful in your education. We don't want you to worry about immigration issues. And as you probably have heard and seen, things are becoming very complicated. So that's our job, to figure out what to do so that you can focus on what's much more important. But once you leave, you're still part of the UCR family. And I want you to know, for those of you who go on and get work experience after that, our office will continue to sponsor your immigration status, but you're more than welcome to come talk to us at any time about any issues that you have. We'll try and point you in the right direction if we're not the ones that can give you the answer, but your family. And I think that's the thing that makes UCR such a wonderful place, and IA just a great connection for you to have, is because we're your new family once you come here, and we're going to be your family for the rest of the time that you're in the United States and working and beyond. So I think those are kind of the general aspects of international students and scholars and IA. But if you have any questions, please type them in the Q&A box, and I'd be happy to answer them. And Marco, if you have anything further you want to add to that, I'd be happy to turn the floor over to you.
Oh, thank you, Michael. Yeah, you explained really well. I mean, yeah, once when you come to United States, visa business can be tough, but that is why we have Michael's team and whole international affairs to help you, so you focus on your studies and enjoying student life. Thank you, Michael.
Well, we have 1 minute left, and I don't see any new questions. So
just a friendly reminder that this session is recorded, and we will be sharing the recording link to everybody after the session. So if you have other questions, feel free to contact Vice Provost Prinsberg through the email address listed on the screen. And next Thursday, we will be presenting the topic on the U.S. classroom culture by myself. And please join us next week at the same time, next Thursday at 6 p.m. Pacific time.
Thank you, John. Thank you, everybody.
All right, thank you, everybody. Have a wonderful Friday and weekend. Thank you. Bye.
thank you.